Hello there, and welcome to Excellent Link Academy. For today, we're trying to discuss a concept under complex number known as division of complex number. So we have done several videos on complex number, right, which you can check out. We have done the addition of complex number, the subtraction and multiplication, even the division of complex number. But today, for today, we're trying to solve several other questions on division of complex number. To check out our last class on complex number, simply check the description of this video. I'll drop the link there. Right. For today, we'll try to consider this question here. The question says, express the following in form of a plus ib. We know that a plus ib is a what? Is a form of representing complex number, which we said it is a rectangular form or Cartesian form of representing a complex number. We discussed in our last class, right? So we are taught to express these two questions here in form of what? Cartesian or rectangular form. So what's our task here? I'm taught to what? This is a problem under what? Division of complex number. How do you solve this? What's the first task? Solution. Let's try to solve this here. Solution. Our first task here is to repeat out the question. I have that 1 plus I to power 3 all over 2 plus I. In this case here, what's your first task? My first task says that these two are dividing, right? These two are dividing. But first things first, observe that my numerator is more complex. The numerator here is saying 1 plus I to power 3. It means that this one plus I to power 1 plus I is multiplying itself 3 times. So in that case here, I'll try to expand this one here. So my first task, pick out numerator. So I'll pick out numerator. My numerator here is what? My numerator is 1 plus I to power 3. I'll try to expand this one here. But if I want to expand this means 1 plus I multiplying 1 plus I multiplying 1 plus I. This means 1 plus I cube means 1 plus I multiplying 1 plus I multiplying 1 plus I. If I want to multiply this will take a lot of time. So I'm going to use the idea of binomial theorem of expansion, like Pascal's triangle. So I'll drop the link in the description of this video, how to expand using the concept of Pascal's triangle. I'll apply the concept here. Recall that we said what we know generally is that if I have a plus b to power 3, this means a cube plus 3a squared b plus 3ab squared plus b cubed. This is the idea behind Pascal's triangle of expansion of binomial theorem. So I'll drop the link in the description of this video so you can know how to expand using Pascal's triangle. So from here now, I'll relate this one here to this. So it means that if I want to expand this one now, the expansion of this becomes, if I have 1 plus I to power 3, the expansion becomes a cube. What's my a? My a is what? 1. So I have 1 cube plus, this is 3, into what's a? A is said to be 1, as a here, 1 here. I have 1 squared. This is b. What's b? B is I here. I have I, that's all. Plus, I have a plus. This is 3. 3, I have 3 down here. Next up, into a. A is 1. I have 1 here. I'll compare them. A is 1, b is I. That's the concept. Into what's b? B is I. That's I squared plus what's b? B is I have I, then I cube here. As in this case here. Proceeding here, my I, if I expand I plus 1 plus I cube will be equal in value to 1 cube is equal to 1. That is 1 times 1 times 1. We give 1. Plus, I have a plus sign here. 3, I have a 3 here. Into 1 squared, we give 1. Next up, I have an I here. I. Proceeding, plus, I have a plus sign here. Next up, I'm seeing a 3. This is 3. Into, this is 1, this is 1 here. 3 times 1 will give 3, as in this case here. Next up, I squared. I can see I squared here. Proceeding, this is plus I cube. I'll have plus I cube. From here, the expansion of 1 plus I to power 3 will be equal to 1 plus 3 times 1 times I gives 3I plus 3I squared plus I cube. I'm here. But again, not something, but we said that I squared is equal to minus 1, and we said I cube is equal to minus I in the last class when we are doing the concept behind multiplication of complex number. We established this concept. So anywhere I see I squared, I'll put what? Minus I. So the expansion for this one is all this. I'm done with the expansion now, but I know that I squared is minus 1 and I cube is what? Minus I. So I'll put them, the value, I'll put it there. So I'll have that 1 plus I to power 3 will be equal to 1 plus 3I, right? Plus 3 into I squared. We said is what? Minus 1. I have minus 1 here. Plus I cube, we said is what? Minus I. From here, the value for 1 plus I cube will be equal to 1 plus, this is 3I, observe, 3I here. Plus minus will give minus, 3 times 1 will give 3. Next up, plus minus will give minus, then I have I. From here, I'll take the real part together and the imaginary part together. By real part, I mean the numbers, numeric value here, and the imaginary part, I mean the part having I. So I'll take the real part, 1 plus I cube will give 1, this is the real part, 1 with what? Minus 3. The imaginary part, this is plus 3I, next up minus I. It's like collecting like terms. From here, 1 plus I cube will give 1 minus 3 will give minus 2, plus 3I minus I will give plus 2I. So this is the value after expanding this one here. From here, when I expanded 1 plus I cube, I had minus 2 plus 2I, right? So if that is the case, I'm having 1 plus I cube here all over 2 plus I. Replace this value here with minus 2 plus 2I. So it means that this one here, which is this now, minus 2 plus 2I all over this one here, 2 plus I. I'm here. So it means that now my next task now is to perform a complex number. To perform what? The division of complex number. I'm dividing this one now. I want to divide this. How do you divide it? In mathematics, not two things. In mathematics, it's not proper for your denominator to be a square root. What do I mean? If I have root A over root B, in mathematics, it's not proper for the denominator to be a root per se. So what do you do in that case? You rationalize. Similarly, it's not proper for your denominator to be a complex number. Yes, that's the concept. So what do? You still rationalize. So how do you rationalize this? If you rationalize, the task there is that multiply numerator and denominator by the conjugate of denominator. So from here, I'll have that minus 2 plus 2I all over 2 plus I multiplied by the conjugate. What's the conjugate of this one? That's 2 minus I all over 2 minus I. If I multiply these two, I'll have minus 2 plus 2I multiplied by this one, 2 minus I all over this one here, 2 plus I into 2 minus I, right? Expand this one here. First task, pick out the first term, minus 2 into everything here, 2 minus I. Second term is plus 2I into 2 minus I. I'm here. All over this one here, first term, 2 into everything here, 2 minus I plus I into 2 minus I. I'm here. What's my next task here? My next task here starts by expanding the brackets one after the other. What do I mean? Minus 2 times 2 will give minus 4 from here. Minus minus will give plus. 2 times I will give 2I. I'm here. Next up, I'm seeing a plus sign here. I'll have plus 2I times 2 will give 4I. Next up, plus minus will give minus. 2 times 2I times I will give 2I squared. That's like the expansion for my numerator here, right? After expanding numerator, I have this value here. So all over, checking first, expand denominator. 2 times 2 gives 4, minus, observe, 2 times 2 gives 4, 2 times minus I will give minus 2I, plus I times 2 will give plus 2I, plus minus will give minus, I times I will give I squared. I have this after expansion here. Proceeding from here, look up please, proceed from here, I'll have that minus 4, next up plus, hang on. After expanding numerator and denominator, I had this. But from here, but what we know is that I squared should be equal to minus 1. What we know, right? So it means that I'll have minus 4 plus 2I, next up, plus 4I minus 2I squared. But we said I squared is what? Minus 1. Minus 1, yeah? So all over, this is 4. Of course, observe here, of course, okay, I have minus 2I, next up, plus 2I minus I squared, we said is what? Minus 1. I'm here. After expanding, after substituting I squared with minus 1, I have this here. Simplify this more better, I'll have minus 4 plus 2I plus 4I minus we give plus, 2 times 1 we give 2. So all over, this is 4. Observe that plus minus 2I can cancel out plus 2I. Left with what? Minus minus give plus. This is 1 here. I'm here, right? We are here after substituting value. Proceeding from here, I'll have that. If I proceed, the next task is to take the real parts together. By real parts, I mean the numbers minus 4 and plus 2, minus 4 and plus 2. Next task takes the imaginary part. By imaginary part, I mean the one having I. So that becomes plus 2I plus 4I. I'll have plus 2I plus 4I. So all over 4 plus 1 gives 5. Right here. It means that at this point here, I'll have minus 4 plus 2 will give minus 2 plus 2I plus 4I will give plus 6I. All over, I have 5 there. I have 5 here. Let's get this done. So minus 2 plus 6I over 5 over 5. Let's get this done. If I want to break this down more better, this can easily be written as, okay, hang on. From there, I'm having minus 2 plus 6I all over 5. This means that if I divide this by this, that is, if I divide 1 plus I cube all over 2 plus I, my value becomes minus 2 plus 6I all over 5. Remember that we said the answer must be in what? Rectangular form or Cartesian form. So it means that from here, I can write my answer as being minus 2 over 5 plus 6 over 5I as my answer after solving this problem here. So now you try to solve the second problem and leave your answer in the comment section below. I'll reply you as fast as I can. Alright, I'll be inviting you guys to my WhatsApp group. I just created a WhatsApp group to help us pursue our academic performance, right? So if you're interested in joining my WhatsApp group, simply DM me, or perhaps what this is my WhatsApp number here, or perhaps you check the description of this video. I'll drop the link to our WhatsApp group there. In our WhatsApp group, we do live video, and also we chat with one another from different countries, right? So all together in order to pursue our academic performance. If you're interested in joining my WhatsApp group, simply check the description of this video, or perhaps you can send me a message through my WhatsApp group. See you in our next class.